Here we go. All right, this is Algebra 1, Lesson 2, Distance Learning. We're doing big ideas. We're doing sections 8.3 and 9.2 together for this. So the big ideas here are graphing, equations of this form, so quadratic equations that are in general or standard form, ax squared plus bx plus c. And we're going to identify the key characteristics like we did last week, but in this case they're in a different form. We're also going to solve quadratic equations by graphing. So the ideas we're using here for just regular graphing, we'll throw a number instead of y, and then we'll graph it and find the answers. So let's go ahead and get started with the general idea for this sort of equation. If we have y equals a number times x squared plus number times x plus number, or minus, these could be subtraction, this could be negative, that could be minus, that could be minus, doesn't matter. The axis of symmetry is always going to be at x equals negative b over 2 times a. So it's this number, so opposite sign of that number, divided by twice the number in front of the x squared. Okay, well actually we'll do some examples with this that'll make more sense. I'm just kind of laying it out for you. So the axis of symmetry, the middle of the graph, is going to be right there. Opposite of that, divided by twice that number. The vertex always goes through the axis of symmetry. So the x number of the vertex is going to be that number. To find the y number of the vertex, what we do is we evaluate the equation at x equals negative b over 2a. So basically you take this number and you plop it in for each of the x's. The answer that you get is the y value for the vertex. The y-intercept is always going to be 0, c. It's going to be this number right here, the number that's all by itself, the number that doesn't go along with the x or the x squared. And then how do you find the other points and how do we graph? So this is just kind of the basic information. I'm just throwing it at you. You can look up things for like why it's that way. It's distance learning. I'm just kind of just giving you the basics here. Sorry for that. So when you have your vertex, you're going to find, for graphing, what you're going to do is you're going to find your vertex. X is negative b over 2a. You replace the x's with a negative b over 2a, whatever that number is. Evaluate, find your y value, you'll get your vertex. And then you're going to look at your a value. Your a value, the number in front of the x squared, is going to work the same way it did with those other ones that were in vertex form. So you'll go 1 to the right, 1 to the left, and you're going to go up 1 times a. Up 1 times a. And then from the vertex, you're going to go 2 to the right, and you're going to go up 4a, 2 to the left, up 4a. Remember we're a, it's 4 times whatever this number is. And then you're going to go 3 to the right, or 3 to the left. Remember this is still from the vertex, so it'd be like 1, 2, 3. And then you're going to go up 9a on each side. So you'll get a parabola. It shouldn't look like a V. It should look like a U shape. Sorry about that. That's just a general idea there. Make sure, and this is what I want to point out here with the other points in graphing, you graph the vertex, and then you graph at least 3 points on the right and at least 3 points on the left. You may have to go further than this. If you have to go further, if you go 4 to the right, you're going to go up 16 times a, because 4 squared equals 16. If you went 5 to the right or left, you would go 25 times a up, because 5 squared is 25. Remember, this is the x squared that kind of controls this function. So, okay, moving on. Let's go to actually do an example. This will hopefully make more sense when we do that. Here we go. So this is going along with the lesson that I put on Google Classroom. So you should be looking at that as you're going through this video. Please make sure you're actually taking notes with this so that you can use those notes when you're doing the assignment. Here we go. All right, so let's dry this off a little bit. Dry, dry, dry. Get it to dry. Wonderful. Awesome. Okay. So here we go. Problem 1. We have f of x. Remember, it can be f of x, it can be y, it doesn't matter. Equals x squared plus 8x plus 7. And we want to graph it, state the domain and range, find the vertex, the x-intercepts, the y-intercepts, axis of symmetry, and where it's increasing or decreasing. We're going to start with the axis of symmetry. So axis of symmetry, and this is at x equals negative b over 2a. So here we have ax squared plus bx plus c. In this case, the a number equals 1, the b number equals 8, the c number equals 7. So when we're doing our negative b over 2a, we're going opposite of this positive 8. So that's negative 8 over 2 times 1. So it's negative 8 over 2, which is negative 8 divided by 2, which is negative 4. So the axis of symmetry is x equals negative 4. Now that tells us our vertex is going to be at negative 4 comma y number. The way we find the y number for the vertex is we take that negative 4 and we put it in for x. So I'm going to go negative 4 squared plus 8 times negative 4 plus 7. Negative 4 squared, remember, is negative 4 times negative 4. And a negative times negative is a... You're right, it's positive. So 16, and then here, 8 times negative 4 is going to be negative 32. And then plus 7. 16 and negative 32 are going to give us negative 16. Plus 7 gives us negative 9. So here I have negative 4, comma negative 9. Now you can use a calculator for this, but if you do use a calculator, make sure you put parentheses. Everywhere there's an x, you put parentheses around the number that you're putting in. Otherwise, the calculator will do the work right, but you'll get the wrong answer. Okay. So now what we're going to do is we're going to graph it, we're going to state domain and range and the rest of the stuff from the graph. Knowing that this graph is opening up because the a value, the thing in front of the x squared, is positive 1. Positive means it's going to go up. If it was negative, it would go down. So like if it was negative x squared or negative 2x squared, it would be opening down. So when I graph this, I know to make my x and y... Ooh, let's make sure I can actually see that. There we go. I need stuff on the left, and I need to go down further than that. Oops, see, I goofed. Whoops, that's okay. I'll just erase and go back with it. There we go. So I gotta go 1, 2, 3, negative 4, 5, 6, 7. And I need to go, right, 1, 2, 3, 4, 5, 6, 7, 8, 9, negative 9. So negative 4, negative 9, that's my vertex. So with that, and it's also my axis of symmetry, I can draw that in, the dashed line. So from here, from the vertex, I'm going to say, hey, the a value is 1. So here, if a equals 1, then I just have 1, 4, 9 as my change from the vertex. So I'm going to go to the right 1, I'm going to go up 1, left 1, up 1. And notice these are all marked off, and I'm trying to be really close, like over 1, up 1. I'm going to go over 2 from the vertex. I'm going to go up 1, 2, 3, 4. Left 2, up 4. So now I'm at negative 5 for my y value there. Now I'm going to go to the right 3 from my vertex. 1, 2, 3. And I'm going to go up the 9. So negative 9 to 0. Right, negative 9 to 9 makes 0. I'm going to go 1, 2, 3 to the left. And up 9. And there's my graph. All right, so we got the graph in green there. We're going to finish off the rest of the questions here. So the domain, here the domain is talking about what x numbers work. So I can put any number in for x and get an answer. So here we say all real numbers. If you want, you can just do R for the domain. That's okay. The range is more interesting. The range is what y numbers do we get? So we look at this and we say, all right, is the graph opening up or is it opening down? In this case, it's opening up. So here, I get all these y numbers up here. So my graph is going up, and it's going to keep going up and up and up and up and up. So I said, what's the smallest y number I get? So as I come down, the smallest or the minimum value is at y equals -9. So the range is all numbers 9 or bigger. And we write that as y is greater than or equal to -9. And this number that goes along with the range, that boundary point or that boundary number is always going to be the y number on the vertex. The vertex is always going to be the biggest or the lowest, highest or lowest point. All right, so we got the domain, we got the range. We want the x-intercepts. So x-intercepts are where it crosses the x-axis. We have one right here. And remember, we write it as a point, -7, 0, and here, -1, 0. Now look at this. I need my y-intercept. So this is x-int, x-int. So I'm like, rats! The y-intercept is going to cross somewhere up here. Does that mean it doesn't exist because it's not on my graph? No, it just means I didn't graph enough. So what I'm going to do is I'm going to go, well, back to my graph. I went 3 over. Now I got to go 4 over. If I go 4 to the right, I need to go up 4 squared, or 16. So this is when x, 1, 2, 3, or 4, x from the vertex. So I'm going to go 1, 2, 3, 4 from the vertex. I'm going to go up 16. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Right there. And then be on the other side as well. So here that's at 1, 2, 3, 4, 5, 6, 7. So the y-intercept is at 0, 7. And remember, it's always at that c value, right? This tells you your y-intercept number. So we really didn't need to graph this part if we remember that this number tells us our y-intercept. So we got axis symmetry, we got vertex, we got x-intercepts, we got the y-intercept, we got domain and range. Now we're going to say it's decreasing. Remember, decreasing as we go from left to right. When's it going down? It's going down all the way on the left until we hit the vertex. So those are all the x numbers that are less than or left than, because they're to the left, less than -4. And it's increasing on the other side, so x is greater than -4. Right, remember the x number on the vertex is always going to be that cutoff for increasing or decreasing. Okay, so that's example 1. We're going to do example 2 now. Here we go ahead and erase this. Okay, so example 2. We have f of x, or it could be y, equals -3x squared plus 6x plus 9. So first thing we're going to do is we're going to find our axis of symmetry, and that's at x equals negative the b value. So 6 is our b value because that's a number with the regular x. So it's this number, -6, or opposite sign of that, because it's a plus, that's a negative, divided by 2a. A is the -3, so times -3. So this is x equals negative 6. 2 times negative 3 is negative 6. Negative 6 divided by negative 6 is 1. So here x equals 1. For the vertex, the x number is the x number from the axis of symmetry. So we've got that. Now what we're going to do is we're going to take this x number and we're going to replace the x's in the equation. So we're going to say negative 3 times 1 squared plus 6 times 1 plus 9. So 1 squared is 1 times negative 3 is negative 3, and then plus 6, and then plus 9. Negative 3 and 6 give us 3, plus 9 equals 12. So it's 1 comma 12. 1 comma 12 is our vertex. So let's go ahead and get graphing. We know our vertex is a positive x and a really positive y, and that our graph is going to be pointing down, it's going to be opening up down. So for this, I'm going to graph here. X equals 1, 2, 3, 4, negative 1, negative 2, 0. I need to go up to 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, whatever. And I'm going to put my vertex on there. So 1 comma 12. There's my vertex. 1 comma 12. Right? And I can put in my axis of symmetry as well right there. Got it. Okay. All right, now I need to put in the other points. Right? I want 3 to the right, 3 to the left, at least, or try to get that. So remember that 1, 1, 4, 9. What we're going to do with these is we're going to multiply them all by negative 3. So that gives me negative 3, negative 12, negative 27. And that's from the vertex. So here, going with my other points, and the reason I multiplied by negative 3, is because we have a negative 3x squared. So if I go 1 to the right or left, I'm going to go down 1, 2, 3. And I'm going down 3 because it's a negative 3. All right, and then if I go 2 to the right or left, I'm going to go down 12. So that's going to put me 2 over, down 12. We're at 12. 12 minus 12 is 0. If I go 3 to the right or left, I'm going to go down 27. Right? This was like the 1, 2, 3 away. So 27, that's going to put me at negative 15. Right? Because 12 and 15 make 27. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So negative 15, negative 15. There we go, and I can just kind of draw the curve through those points. Notice how I counted out where each point went, and I mean, it doesn't look perfect, so I'm drawing it, kind of by hand, but you can see that I drew it out and counted it out. All right, so now we got to answer the other questions. So domain, actually, let's go x and y-intercept first. Y-intercept is at 0, 9. We can see that on the graph, right? Because it's at 0, 9. And it's the C number, the last number, the number that doesn't have an x in it. So if I put 0 in for x, we're just left with 9. Okay, so at 0, 9, the x-intercepts, one of them is here where the graph crosses the x-axis. That's at 3, 0. Notice how I'm writing these with an x-coordinate and a y-coordinate. The other time where the graph crosses the x-axis is right here, x-intercept at negative 1, 0, right there. So we got our x-intercepts, we got our y-intercept, we got our axis of symmetry, we've got our vertex. Let's talk domain and range. The domain is all real numbers, which we can just say are little blackboard bold R with a double line on it. And now the range is more interesting. The range, here the graph is opening downward. When the graph opens downward, it means it has a maximum or a highest number for the y. And then it gets all the y numbers below it. So we look and we say, hey, what's the biggest y number? Right there. That's at y equals 12. notice it's always the y number of the vertex. So the range in this case is y is less than or equal to 12. 12 is the biggest y number, and everything else on this graph has a y value smaller than or equal to 12. It'll never pop back up above 12. All right, now increasing, decreasing. It is increasing here, because we always go left to right with increasing, decreasing. As I go from the left to the right, starting from the left, it's increasing, 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 top, decreasing, 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 decreasing. So it's increasing all the way up to the vertex at x equals 1. So it's increasing for all the x's that are less than 1 on the left side. It's decreasing for all the x's that are greater than 1, all the x's on the right-hand side. Okay, so that's the graphing part. The big idea, the trickiest part, is identifying the vertex. I'm just going to go over it one more time. What we do is we go opposite of this number divided by 2 times that number. That gives us our axis of symmetry, which is the x number of the vertex. And then we find the y number of the vertex by replacing x with whatever this number is. And then evaluating, you can use a calculator for this if you want, getting the y number. The answer is the y number. Okay, so now let's go ahead and talk about solving by graphing. So there's a couple methods you can use to solve by graphing. Method 1, what you can do, well, give me a moment. I'm going to teach you 2 methods. You can choose to use both, either one, doesn't matter, one or the other. So I'm just going to jump to the 2 examples here. Example 1, we have -6 equals 2x squared plus 12x plus 10. Problem 2 is 7 equals -x squared plus 8x. All right, so let's look at problem 1. What we can do here for problem 1. Notice we have number equals stuff with x's and x squared. Number equals -2x squared plus 12x plus 10. What we could do is we could add 6 to both sides and get 0 equals 2x squared plus 12x plus 16. With this here, what I can do is I can graph 2x squared plus 12x plus 16. So graph this, graph y equals 2x squared plus 12x plus 16, and then find the x-intercepts. Those are the answers. Those are our solutions. The x-intercepts are when y equals 0. If we graph that, and we find the x-intercepts, that's when y is equal to 0. So let's go ahead and do that. So we don't need to go through every other step. We just got to graph it. To graph it, the first step, drop my pen. First step for graphing is we're going to go axis of symmetry, which I'm just going to call AOS, is x equals -b, so -12 over 2 times a, which is 2 times 2. If this were a -12, that would be positive. Okay, we would just switch. It's the opposite sign up there of that one. So here, this is x equals -12 divided by 4. 4 because 2 times 2 is 4. X equals -3. So now we can put our vertex on there, which is going to be -3 comma. I'm going to replace the x's with -3. So I get 2 times -3 squared plus 12 times -3 plus 16. So I replace the x's with -3's. So here this is 2 times 9 minus 36 plus 16. 2 times 9 is 18 minus 36 plus 16. That's negative 18 plus 16, which is negative 2. So I have, excuse me, I have negative 3 comma negative 2 as my vertex. So if I'm going to graph this, 1, 2, 3, negative 3, negative 2, there's my vertex. I notice the a value is 2. So that 1, 4, 9 is going to get multiplied by 2 to give me 2, 8, 18. So from here, I'm going to go right 1 up 2, left 1 up 2, right 2, and I'm going to go up 8. 1, 2, 3, 4, 5, 6, 7, 8. Right, and that's at 6, right? This is a 6, because it's 8 above negative 2. Right, and then we could graph the next one. We could go right 3 from the vertex, and we go up 18. Right, 1, 2, 3, that'd be up here. And it's actually going to be at 16. But we don't really need to do that, because remember what we're doing is we're solving by graphing. So we've got a good picture of the graph here, and we want to find the x-intercepts. The x-intercepts, we've already got them, so we don't need to really graph much more. So here we just have the x-intercepts at negative 2 comma 0 and negative 4 comma 0. So the solutions are x equals negative 4 and x equals negative 2. So that's one way to solve by graphing. And make sure you write your answers. Solutions, x equals x-intercept number, x equals x-intercept number. Because it's initially goes back to this. If I put negative 2 in for x here, into that, the answer would be negative 6. If I put negative 4 in for x, the answer would be negative 6. All right, so backtracking just a little bit. If I want to solve this, one way I can do it, I can add 6 to both sides. Graph y equals this, where it's equal to 0. Graph it, find the x-intercepts, pick the x numbers from the x-intercepts. Those are my solutions. Okay. Method 2. Method 2, what we can do is we can graph two things. Excuse me, I'm going to drink a little bit of water. So, if I wanted to use method 1, I would subtract 7, get 0 equals negative x squared plus 8x minus 7. I would graph negative x squared plus 8x minus 7, find the x-intercepts. But we can do something else. What I can do is I can graph y equals negative x squared plus 8x, and I can graph y equals 7. So I'm going to graph y equals that side, and I'm going to graph y equals that side. I'm going to find where they cross. So find where they intersect. So we're going to do that. This is method 2. You can use either one. You could have done that here. You could have graphed 2x squared plus 12x plus 10. You could have graphed y equals negative 6 and found where they cross. They would have crossed at x equals negative 4 and x equals negative 2. Okay. So I'm going to graph this first. So here we just have y equals negative x squared plus 8x. So I'm going to find the axis of symmetry at x equals negative b, so negative 8 over 2 times negative 1. Negative 1 is my a number because I have a negative x squared there. So negative 8 over negative 2 is going to be 4. So x equals 4 is the axis of symmetry, which gives me a vertex at 4 comma, and now I need to replace the x with a 4. So, because I know the x number on the vertex is 4, because that's what my axis of symmetry is, so now I got to find the y number when x equals 4. So I put in a 4 for x. I have negative 4 squared, and notice it's negative, and then 4 squared, plus 8 times 4. So it's a negative 16 because 4 times 4 is 16, then the negative of it, plus 32 just gives me 16. So 4 comma 16 is my vertex. And I've got a negative in front of the x squared, so it's like a negative 1 for my a value. So that 149 is going to get multiplied by a negative 1 to be a negative 1, negative 4, negative 9. So let's go ahead and graph this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. All right, 1, 2, 3, 4, 5, 6, 7, 8. Good. All right, so 4 and 16, right about there. And then I'm going to go 1 to the right or left, and I'm going to go down 1. So that's at 15, because 16 minus 1 is 15. And I'm going to go 2 over, I'm going to go down 4. So that's 16 to 12, because 16 minus 4 is 12. That's why. And then I'm going to go 3 over, 1, 2, 3, and I'm going to go down 9. 16 minus 9 gives me 7. There it is. There it is. I can graph this U shape in. Now I'm going to graph the line y equals 7. Remember, y equals 7 is a horizontal line. It goes side to side. So I go to 7 right here, and I draw a horizontal line across y equals 7. And I see that the graph intersects at x equals 1 and x equals 7. So, right, this is at 1 comma 7, that's the point 1 comma 7, that's the point 7 comma 7. Whoop. So the answers are x equals 1 or x equals 7. Just the x numbers, because really, remember, we're just solving this equation. All right, so to recap, 2 options when you're given a problem like this. Option 1, you make it equal 0 by doing the opposite of whatever's on the left. Graph the remaining thing on the other side of 0. Graph that parabola, and then find the x-intercepts. The x numbers from the x-intercepts are your answers. Option 2, you graph the parabola that's given to you, or the quadratic, just graph that here, and then draw a horizontal line about y equals whatever number, so that's 7, and find where this graph has a y value of that.